Here's another nice question that deals with the rotation of something and using the idea of radians to help us figure out a distance. So I've got a Ferris wheel. Whoops. Here's a Ferris wheel with seats, people on the seat, etc. And it's a diameter 24. Okay, we don't like diameters, we want radius. So it has a radius of 12. And so it says, what will the distance traveled be to go around once? Okay, so if I start on here, and that's a bum ray. Oftentimes you only get to go around once or twice on a Ferris wheel, but whatever. Anyway, if you start there, what is the distance to go all the way around to get back to there? And that would be known as the arc length, or S. So I know that the radius is 12, and I don't know any other numbers other than it says it goes around once. So if the thing goes around once, then that rotation is 360 degrees. But if I'm going to use any of these formulas up here, all of the angle measurements are in radians. So I need to convert that to radians, which is 2 pi. So if my radius is 12 meters, and if my rotation is 2 pi, then I should be able to figure out the arc length. So I have a radius, and I have a rotation, or an angle. So I have an angle, I have a radius, and I'm looking for that. That's a formula I'm using. So theta equals S over R. I'm searching for S, so I'll multiply both sides by R. So I get S is equal to R times theta, and R is 12 meters times the angle is 2 pi equals S. So you would go 12 times 2 is 24. You would go 24 pi meters. Now, I don't know if they say to go to a decimal place. Oh, okay, so on your calculator, let me do that. Some people just do a shortcut and just call pi 3.14, but unless they specifically tell you to use that on your calculator, I would always just use the pi button on your calculator. So don't use 3.14 unless they specifically say to use it. So 24 times pi equals, and I get the arc length, I will have gone 75.398. They want one decimal place. So 75.4 meters. That would be the distance of going around the whole outside once. Now, just while we have that as a follow-up question to that one, is I could do this kind of thing. And I could say, well, if the time it took to go around once was, say, 12 seconds, you could figure out how fast you were going. So the angular velocity, yeah, we could figure out an angular velocity. So the angular velocity would be equal to the angle, so that would be 2 pi. That's how the rotation that we went, divided by 12 seconds. So your angular velocity would be, what would that be? Pi over 6 radians per second. And if we wanted to go a little further, we could actually figure out your velocity, how fast you're going. So the radius is 12 times, I shouldn't have used the same number as the radius for the time, whatever. And your angular velocity is pi over 6 radians per second. Oh, and the radius is 12 meters. So your velocity would be 12 divided 6 is 2, so it would be 2 pi meters per second. That's how fast you'd be going. Or roughly 6.28 meters per second, which is fairly fast, actually. Now, if you wanted to keep going, and I'm sure that you do, you could figure out how fast that would be in, say, kilometers an hour. That might be a better number to use. So if I said I have 6.28 meters in 1 second, I could times this by 3,600 seconds are in 1 hour, so seconds cancel. And meters, I could say there's 1,000 meters in 1 kilometer. So if I take the 6.28, let me do that. I'm going to go back to the 2 pi thing. So 2 times pi, 6.28 something and change, times 3,600, divided by 1,000. So on that Ferris wheel, you'd be going 226.2 kilometers an hour. I'm not thinking that that would be the speed or the time it would take you to go around the Ferris wheel. It probably would be significantly longer than that, because that's a little quick for a Ferris wheel. All right, hopefully that helps you figure out that question.